Good morning friends, I welcome you all in this session. As you are aware, in previous session we were discussing about cost of quality, and we have seen that there are different costs of quality. We have seen appraisal cost, maintenance cost, we have seen internal and external failure cost, right? And we have also seen different types of definitions as far as quality is concerned. We have defined quality as inversely proportional to variability, right? And we have seen other definitions as well. We have seen different dimensions of quality, and there were 8 dimensions, and there were 3 aspects of quality: quality of design, quality of conformance, and quality of performance, right? Okay, let us move on to the new topic, and it's about what are different sources of variability in a product. So, as I said, every organization wants to produce quality product, but because of certain reasons they do not achieve this particular objective, and there are multiple reasons. You can have internal and external reasons, you can have chance causes and assignable causes, right? We will see these 2 causes in detail. So, if you have got certain inputs in your process, then you will have these outputs. These are different outputs, and output can be a product, can be a service. You can have byproduct, you can have waste, and you can have some tangible, you can have some learning, right? So, learning is also possible. Now, we want to remove variability in the process. So, we want to know how our quality is getting affected by different factors, or let us call them different independent variables. So, we want to find out which are most influential variables which affect value of y. So, y can be quality, can be productivity, can be efficiency, or some other objective, right? Let us say space utilization, let us say minimization of conflict. So, you can have several values of y, right? So, y is your response variable, right? So, once you know which are the most influential variables, you need to set these influential variables in such a way that y is near nominal requirement, right? We should determine where to set the influential variables so that variability is small. This is our objective, right? And we want to set x variables in such a way that the effect of these z, which are uncontrollable variable, so that effect is minimized, right? Now, let us look at something about different types of quality levels. Most of you would be aware of that there is something called 3 sigma quality, and sigma is nothing but standard deviation. So, if there is a distribution and you have got mean at the center, and then plus minus 3 sigma. So, that curve will have area approximately equal to 99.73. So, if you are operating at 3 sigma level quality, then if you produce 100 products, then out of 100 products 99.73 products would be confirming, right, would be right products, right. Now, suppose let us take an example. There is a product which has got 100 parts, and the probability that one particular product which is made up of these 100 parts would be confirming at 3 sigma level is 99.73, right. What is 3 sigma quality? It is you are producing 99.73 products properly, right. So, if there is a product which consists of 100 parts, right. So, if you assemble these 100 parts you will get one final product, right. the probability that any specific unit of product is conforming is what? What it would be? It would be 0.9973 to the power 100, right, isn't it? So, at the end of the day your quality is 76.31%. Now, would you like to have such a level of quality? No, I do not think you would like to have such a quality level that out of 100 final products you would be having 76.31 correct products, right. So, there are certain problems with 3 sigma limits, right. Now, if you follow let us say 3 sigma limit, then there would be 20,000 wrong drug prescription each year. If you follow 3 sigma limit, then more than 15,000 babies would be dropped accidentally by doctors and nurses each year. Would you like that to happen? No. You will have 500 incorrect surgical operations per week. You have got 2000 lost pieces of mail each hour. You do not want all these things to happen, right. So, if you work at 3 sigma limit, your quality would be very poor. So, that is why you need to reduce variability in the process. So, when you reduce the variability, your quality level will increase, right. Let us look at something called 6 sigma. Nowadays everyone is talking about 6 sigma. 6 sigma is basically a concept wherein we reduce variability in the process, and we reduce variability so that the specific limits, you have got upper specification limit and lower specification limit. So, these two limits are 6 standard deviation away from the mean, that is 6 sigma. What is 6 sigma? 6 sigma is a process of reducing variability in the process, and the mean value is 6 standard deviation away from upper and lower specification limits, right. So, that is 6 sigma, and there are different approaches to achieve 6 sigma quality. So, you have got DFSS, design for 6 sigma, right. Let us say if you are coming up with entirely new process, so you need to design the process initially, right. But if there is an existing process and you want to implement 6 sigma, then there is an approach called DMAC approach. We will see this approach little later, right. So, there is something called 6 sigma, right, 6 sigma quality. We will look at how many parts would be defective at 6 sigma quality, right. Now, look at these two pictures. So, this is A, right, normal distribution centered at target. So, this is your distribution and this is your mean, right, mean is here. So, mean is here, right. So, you have got plus 1 sigma, plus 2 sigma, plus 3 sigma, similarly this side also. But if you look at in this figure, this LSL, lower specification limit and upper specification limit, they are 3 standard deviation away from mean, right. This is your mean value, right, and this and these two limits are 3 standard deviation away from mean, plus side and minus side, right. So, if you operate at 3 sigma limit quality, then as I said, you would be producing 99.73 good products, right, and if you convert it into parts per million defective, then you will have 22,700 parts per million defective if you operate at 3 sigma level, right. Now, let us look at this picture, right. Here this is normal distribution with a shift of 1.5 sigma limit, with 1.5 sigma shift in the mean. So, what we are saying in 6 sigma, that whenever there is a process going on, we will assume that its mean will shift 1.5 sigma towards positive and 1.5 sigma towards negative. So, there is a shift of 1.5 sigma both the sides, right. So, in this way this is your mean and this is your upper specification limit and this is lower specification, this upper specification limit and this is lower specification limit, right. So, mean is 6 standard deviation away from specification limits, right. So, if you look at the number of parts per million defective at 6 sigma, it is 3.4 parts per million defective, right. So, this how you should get this value 3.4 ppm defectives. We should, whenever we are saying that we should get whenever we say that in 6 sigma the number of defectives are 3.4 ppm, we should always say that with a shift of 1.5 sigma limit, right, with a shift of 1.5 sigma both the sides, right, left side as well as right side. So, this is 6 sigma concept. Now, I talked about this PDCA cycle when we were talking about project control. So, one of the methods of project control is PDCA cycle, right. So, you should plan, you should do, then check whether you made any mistake or not, and then act, right. So, this is known as PDCA cycle, applicable almost everywhere. When in our daily lives we plan something, then we execute that whatever we have planned, and then we check, we compare it with whatever we have done with the planned one, right. So, if there is any difference or if there is any variation, then we act it, right. We try to minimize that deviation between whatever we have planned and what we have done, right. So, Deming's PDCA cycle. Now, the 6 sigma approach, which is DMAC, is refinement of this cycle only. So, this is 6 sigma process, and the approach is DMAC approach. So, define, measure, analyze, improve and control. So, what to define, what to measure, right. So, let us look at this 6 sigma process. Let us look at something more about 6 sigma quality. So, 6 sigma is basically a philosophy and set of methods, because in 6 sigma you would be applying several statistical tools to reduce variability. So, it is a set of methods, especially statistical methods. So, these methods can be used by a company to eliminate defects in the product or in the process, right. Of course, objective is to reduce variability. The name 6 sigma refers to the variation that exists within plus minus 3 sigma. This standard deviation is nothing but 3 sigma, right. So, 3 sigma of the process output. 6 sigma allows managers to readily describe process performance using a metric called DPMO, it is defects per million opportunities. So, let us say if there are 2 processes going on and you want to compare those 2 processes. So, how will you compare? And there is a common method, a common metric is DPMO, defects per million opportunities. So, if in first method DPMO is more, then that is not a good method, right. So, you should have defects as low as possible, right. So, 6 sigma, it is basically what DPMO can be used to compare multiple processes performances, right. So, defect per million opportunities, this how you can calculate this value. So, number of defects divided by number of opportunities for error per unit. So, this is opportunities, right, into number of units multiplied by 1 million, right. Okay. So, this is the formula for calculating DPMO, defects per million opportunity, right. So, let us look at one example and we will calculate what is DPMO in that example, right. Suppose we observe 200 letters delivered incorrectly to the wrong addresses in a small city on a particular day. When a total of 200,000 letters were delivered, what is DPMO in this situation? So, we have observed 200 letters were delivered incorrectly out of 200,000 letters. Calculate defects per million opportunities, calculate DPMO. So, we know what is our formula is this, right, number of defects. So, in this case 200, number of opportunities for error per unit, it is 200,000, right, is not it. Let us look at this answer. So, in this case these are total number of units, right, number of opportunities for error per unit is 1. So, answer is this 1000. So, what we will say that? We will say that for every 1 million letters delivered in this city, postal managers can expect to have 1000 letters incorrectly sent to wrong addresses, right. So, this is how you can calculate DPMO. Now, let us look at Six Sigma approach, right, and the approach is DMAC. DMAC is the approach to improve existing processes, right. So, let us look at DMAC approach. The first is it is developed by GE, and the overall focus of the methodology is to understand and achieve what the customers want, right. So, with this focus in mind, Six Sigma process has been developed, right. Okay. So, D stands for define. You should define what customers want or what is the problem, right. You see, in a product, a customer may want, let us say, first requirement is availability of the product, right. For me, the first requirement is that it should be at reasonable price. For someone else, the priority is it should be durable product. For someone else, it should be reliable product. So, each one of us has got different requirements. So, first of all, define what is the requirement. If there is an existing process, let us say if you want to minimize number of transactions which are taking place in banking sector and you want to minimize the incorrect transactions. So, first of all, define what is the problem, right. Once you define problem, then you measure it. It should be measurable. There should be some number, isn't it? How to measure? There are different tools available. For defining problem also there are certain tools available. Then you have got analyze the problem. Analyze what? What are the reasons for that particular problem? There might be several reasons, there might be one reason, right. So, analyze the cause and effect, what are the causes and what are the effects, right, and there is something called cause and effect diagram, we will see that diagram. Then you have got improve. So, once you have analyzed, you should try to find out, find out solution, right, remove the reasons for that particular defect. If the defect in the process is due to, let us say, worker, then you need to train worker, right. So, this is how you improve it, right, and finally control, right. You maintain whatever you have done in fourth step, right. You should see that now no problem should occur, right. So, this is DMAC approach, and there are different tools, as I said, available for each of these stages, right. We will look at couple of Six Sigma tools, and one of them is flow chart, and there are several types of flow charts. One of them is this, how we are receiving material from vendor. So, let us say material received from supplier. So, you have placed an order and now you have received it, right. So, what to do now? Once you receive material from supplier, you need to inspect it, right. Why you should inspect? Because you do not want to accept faulty raw material, right. So, you just check it for defects, right. If there are defective parts, you should return those defective parts. Now, this is again a very important step here. Are you checking each and every part which you have received from vendor, or you are going for sampling, is not it? So, if you are going for sampling, then you need to decide what should be the sample size. Let us say if you receive a lot of, let us say 1000 nuts, right, or 1000 bolts, right. So, you have received a lot containing 1000 bolts. If you pick 5 units and if you get 3 defectives, then either you reject the whole lot or you should not reject the whole lot. It depends upon the agreement which you have signed with the supplier initially, right. So, at this stage you need to decide whether you are going for sampling or you are going for 100% inspection of those 1000 bolts, right. So, that is a decision you need to take here, right, at this level, right. So, if you want to return it, return to supplier if lot is defective, otherwise accept it, right. This is a very simple flow chart. So, you can have different types of charts, main machine chart, then you have got 200 process chart and so on, right. So, this is one of the tools, right, flow chart, and there are some other charts we will see. So, can be used to find out quality problems, right. Then you have got run chart. In run chart, let us say there is a process and at different time intervals you are collecting let us say sample to check its quality. So, let us say again you are making a wire, right. So, first hour when you checked, you just picked up one wire and you checked its diameter 0.5 centimeter, right. Second hour you just picked one more wire, diameter less than 0.5 and so on, right. So, this is how you will develop a run chart, right. So, you are measuring quality over a period of time, right. So, what is the purpose of this type of chart? Can be used to identify when equipment or process are not behaving according to specifications. See, the point here is this is run chart, this is not a control chart, right. So, you will get an idea in what direction your process is going, because if you look at this particular chart, there is an increasing trend, right. Just see this, if you fit a line over these data points, then you will get an increasing trend, and it is possible that after, let us say, this chart is only for 12 hours, right. It is possible that after 24 hours the process might go out of control, right. So, run chart is an important chart. It will help you in knowing the trend of the process, right. Let us look at one more chart. It is called Pareto chart. This is applicable in almost all the situations. So, let us say in a process, or let us say in an organization, there are several defective parts. Let us say we have found that 80% faults are due to design problems. Then very few percent defects are due to not following assembly instructions, not properly purchasing right product due to workers problem, and these defects due to some other problems. So, this is nothing but a Pareto chart. It is also known as 20-80 rule, right. So, we will say that in an organization 80% quality problems are due to 20% defects, is not it, and this rule you can apply as I said almost everywhere. In a class 80% problems are due to 20% naughty students, right. Let us say let us take one more example. In a car 80% of the cost is because of some important 20% items or 20% parts, is not it. So, you can apply this situation in almost everywhere. So, this is known as Pareto analysis, right. So, can be used to find when 80% of the problems may be attributed to 20% of the causes. Very important chart, and you should look at this chart carefully. So, let me summarize what we did in today's session. We have looked at what is Six Sigma, we have looked at what is DMAC approach, we have looked at how to find DPMO, and we have looked at couple of Six Sigma tools, right. So, in next session we will continue with some other tools of Six Sigma. Thank you very much.